Horizontal scaling versus vertical scaling. So if we take an example of vertical scaling, we can consider a PostgreSQL database which will be having a server, storage, RAM, and a server with a CPU, storage, RAM, and PostgreSQL running on it. If we want to scale this setup, what we would do in vertical scaling is we would take more RAM and more storage and we would add it to the same server rack, which would make the requests more faster and could handle more requests, but a single server is doing that. So this is vertically how we scale it. What if we want to add more server space? What if we want to add more computational power? In vertical scaling, we would add more RAM and more storage. At one point, it limits the capacity of the server. So, what we would do is add another server. So, we would take the server rack and we would add another one on top of it. So, that is the reason why it is called vertical scaling. What happens in this case is that the system scales, but it is too expensive to configure same servers, same type of servers. You need same type of servers with configuration that matches each other, and it becomes very costly to scale in such a way, in such a manner. On the other hand, if we see horizontal scaling, whenever we want to scale horizontally, what we would do is, for example, we have a MongoDB over here which will be having which will be running on a server having its own CPU with a storage and RAM. But what if we want to scale this? If we want to scale this, we could create another server with the same configuration. We could just set up another server with the same configuration. This time, this server doesn't have to be running the same operating system as the first one. So therefore, horizontal scaling is more cost effective. Now we have two replicas of the same MongoDB over here and over here. The issue here is that we have to sync both of the MongoDBs. So we could use a master slave architecture to do that, where one master node would sync up the slave nodes, and sometimes the slave nodes can only handle read operations. So that is how we scale horizontally. At times, due to the usage, due to the user requirement, we tend to use a hybrid approach of both of them. So whenever we need more scalability, we use we use the horizontal scaling. In this case, shown with an example of MongoDB. Whenever we need fault tolerance, if one server goes down, if for example this server goes down, we have a replica set in this server, so we can rebuild this server whenever the system is back up. So whenever we need good fault tolerance and we need good scalability, we use horizontal scaling. Whereas in terms of data consistency, if we need consistent data and if we need faster communication, we use vertical scaling. For example, in banking applications, we need high compute power. We need fast transactions to happen. So for that, and we need consistent data for it. If a transaction is happening, the money has to be deducted from one account and it will be added to the other account, else the transaction will be rolled back. So therefore, in those scenarios, we tend to use vertical scaling to scale the systems. So that was it. See you next time.